Hello guys, welcome to the first lecture of rigid body dynamics. So we'll learn the definition of rigid body dynamics, the very basic principles that governs, and we'll derive some of the formulas that will be helpful. So let's begin with the definition itself. So what is a rigid body? So as written there, a rigid body is defined as a system of particles in which distance between each pair of particles remains the same. This line, that distance between each pair of particles remains the same. This is the fulcrum of rigid body dynamics, which means that at any condition the distance between two particles must not change. So we'll understand the definition by a few examples. So let's get started. So I'm taking example 1 here. That imagine there are two body A and B, okay, and if we say that A is moving with velocity 5 meter per second and B is also moving with velocity 5 meter per second, so A plus B, if we consider A plus B as a part of a system, do they constitute a rigid body? The answer is yes, they do, because their distance will not change because the relative velocity is 0. Let's take another example where this will not hold true. Again, the same kind of system but with a different velocity. So there is A and there is body B. This is moving with 10 meter per second and this is moving with 5 meter per second. Now in this condition, if we consider A and B as a part of system, do these two particles constitute a rigid body? The answer is no, because since their velocities are different, their separation will change with the passage of time. Okay, so this is the very basic idea with the rigid body dynamics, and this is the very important line that will govern entire rigid body dynamics further. Okay, so now let's talk about general argument about rigid body dynamics. Now let's consider a rigid body, okay, and we are taking two particles, particle B and particle A, okay, and let their velocity be BA and BB, okay. So if they are a part of rigid body, then their separation will not change. If let's say if this separation is, let's say, R, this R will remain same always at every possible condition. And so if their separation is constant, why constant? Because it is given that they are part of rigid body, therefore their separation will be constant only if this condition holds. Their velocities in the line joining them should be same, so this condition must hold, that velocity in the line joining them must be equal. Only then the separation will be constant. And if this is true, then we are left with just perpendicular velocities, and this is VA sine theta 2 and this is VB sine theta 1. Okay, now since their separation is not changing, we can actually treat that they are joined by a rigid rod. Okay, we can hypothetically imagine why we are capable of doing that, because it is given that their separation will not change, and because their separation will not change, so we can imagine them as two particles connected at the end of a rigid rod. And for these two velocities, the first condition would be, what if VA sine theta 2 equals to VB sine theta 1? If these two velocities will be same, the rod will move like this, and for this particle will be at rest. This will hold true if this condition satisfy, if both velocities are same. What if these velocities are different? For example, VA sine theta 1 is not equals to BB sine theta 1, this is VA sine theta 2. If these velocities are not equal, then this will move into a circle. For example, if this end of marker is moving faster, then this will move in a circle. Okay, so from here we make a very important line, that motion of one particle with respect to other in a rigid body, is either rest or circular motion. Okay, and I hope I explained that. I will try to explain to once more. Because the separation is not changing, we can assume that there are two particles connected at the end of a rod. Now the two cases appears if these two velocities are same. If these two velocities are same, the particles will move like this. But if these two velocities are not same, then if this velocity is greater, they will move in a circle like this. But if this velocity is greater, it will move in a circle like this. So motion of one particle with respect to other in a rigid body is either rest or circular motion. This is again a very important line in rigid body dynamics. So now let's derive some of the equations. And this is actually a very important line, that every particle with respect to other in a rigid body moves in a circular motion or remains at rest. We will use this line to prove some of the formulas that are very essential in rigid body. So let's go there. Now we will learn about types of motion of a rigid body. So it is very obvious that there are two types of motion. The first type is, which we have learned in class 11, the first type is pure translational motion. Pure translational motion. Okay, so this is the first type of motion a rigid body can perform. In this, what happens is, let's say the particle number 1, this is particle number 2, this is particle number 3, this is particle number 4, this is particle number n. Okay, there are n number of particles. In pure translational motion, distance traveled by each particle is same. So this is again particle number 1, this is particle number 2, and this is particle number 3. So distance traveled by each particle is same. If this is x1, this is x2, this is x3, then in pure translational motion in a rigid body, all particles travel the same distance in same amount of time. So we can write that x1 equals to x2 equals to x3 equals to xn. Okay, now from this fact, and because all particles have moved same time interval, all particles have moved in the same interval of time, so we can also say that velocity of 1 equals to velocity of 2 equals to velocity of 3 equals to velocity of 4 equals to velocity of n. Why we are saying that? Since all particles have traveled the same distance, so x1 equals to x2 equals and these are equal, this is equals to xn, and we define velocity as distance by time. So if time is same for every particle and given distance is also same, velocity will be the same for every particle. So now if we write the kinetic energy of body system, let us call this body a system, kinetic energy of system, then we will write individual kinetic energy of all particles. So half m1 v1 square plus half m2 v2 square, and this will go up to nth particle, and this is half m n v n square. We treat that mass of every particle is same, therefore m1 equals to m2 equals to m3. So we can take out, and we also know that velocity is mass is not same, given velocity is same, so we can take velocity out. So this is half v square, and this is m1 plus m2 plus m3 all add up to mn, and this is actually mass of the body. So this is half m v square, this is mass of system. So this is how we find kinetic energy of a rigid body where velocities of all particles is given. So that's the kinetic energy we find. Now we will talk about the second type of motion a rigid body performs. So and that is pure rotational motion. So let's talk about that. Now let's talk about pure rotational motion. We knew that every point on the body moves in circle whose center lies on the axis of rotation. Okay, now let there a body like this. Okay, and this is the axis through which the body is rotating. Let's say this is moving with omega. Okay, so every particle will move in a circle. Let's say this is particle number 1, so this will move in a circle of radius r1. This will move in a circle like this. This is particle number 2, so this call is radius r2. This is particle number 1, this is particle number 2, so this will move in a circle of this unit. So every point on the body moves in the circle whose center lies on the axis. So, and they will move in a circle whose center lies on the axis, and every point moves through the same angle during an interval of time. Because they are moving with same omega, therefore, and omega is actually defined as delta theta by delta t. Okay, so because they are moving for same interval of time and their omega is same, therefore this quantity must be same. So every particle will move equal amount of angular displacement in equal interval of time. So, and if this is, so this particle is also moving with omega, so we can assume their translation velocity is v1, this is v2. Similarly, there will be a particle n with moving with radius rn in a circle with center lying on the axis of rotation. So we can write that velocity of one particle is omega times radius of one particle. Velocity of second particle is omega times radius of second particle. This way we define velocity of n particle is omega times radius of nth particle. Okay, now kinetic energy of body in pure rotational motion equals to half m1 v1 square plus half m2 v2 square plus half m3 v3 square all the way up to half mn vn square. Okay, we will substitute the values of v1 from here. Okay, so this is half m1 omega r1 square, omega 1 r1 omega square r1 square. We will write half m2 omega square r2 square, and we will continue adding up to half mn omega square rn square. Okay, now because omega is common in every term, so we will take omega out. So we are left with m1 r1 square plus m2 r2 square and all the way up to mn rn square. So, and this is half omega square. So, and this term we define as I, and this term we call moment of inertia. We will talk about that, but just for the sake of naming it, we are calling it I. So this is I1 and this is I2 and this is In. So moment of inertia of first particle all the way adding up to nth particle. So this becomes half I of the system into omega square. So this is how kinetic energy in a pure rotational motion is defined. That is, in more general term we write it as half I omega square. So that's how we define kinetic energy in pure rotational motion. So I think this would help you, and this all for today. I think this would help you. So like, share and subscribe. We'll see the next lecture and we'll talk about moment of inertia, and we'll derive some of the moment of inertia of some of the particular bodies like rod and hollow sphere and solid sphere. Till then, take care and like, share and subscribe. Thank you.